Hello, class. Welcome back. This section is going to cover permutations and combinations. This is section 4.4. Right. And so let's go ahead and get started. Let's jump right into it. Right. One thing I want to mention real quick is make a note of this. Right. With permutations, order matters. With combinations, order does not matter. Right. And, as we're going through these problems, we're going to go ahead and, realize what is the meaning of it. And what I want, the first example I'm going to look at is how many different ways can I arrange the numbers 1, 2, and 3, right? How many different ways can I arrange the numbers 1, 2, and 3? So one way, right, and you may be saying, hey, how is this applicable, right? Let's just say that you have these action figures, right? You have a Transformers there, you have a Godzilla there, and you have Iron Man on the last one, right? And you want to know how, what different ways can you arrange these on your shelf, right? You can have Godzilla in the middle, you can have Godzilla in the end, or you can have it in the front. You can have Iron Man on the second spot, and so forth, right? There's a few, right? There's a few different orders you can have these in, right? You can arrange these in, but we're going to go ahead and show this with numbers, right? We're going to go ahead and just show this with numbers, right? Which is 1, that's a 2, and that's a 3. And this is going to be with repetition not allowed, meaning you can only use the number 1 once, you can only use the number 2 once, and you can only use the number 3 once, right? In other words, you only have one of each, right? One of each. All right. So to start, right, you want to do these in a pattern because you really don't want to you want to keep track of of all the shuffling that's going on, right? You want to keep track of all the shuffling that's going on. So the first one that I like to do is imagine these numbers are in a row and number 1 moves forward. Number 2 is going to move forward as well. And number 3 moves forward too, but he's going to go back to that first spot, right? That's a different way you can arrange these numbers, right? A different way you can arrange them would be, again, 1 moving another step forward, 1 being here, then 2 is there, and then 3 is there. Right, so pushing all these numbers in a line is going to be a way you can get a set. You can go ahead and get You can go ahead and get an arrangement, right? Right. So whenever I'm doing these by hand, right? This is one way that I can show, right? Another way would be you start with the first element, right, which is 1. And instead of writing 2, 3, right, I'm going to lock 1 in. And the only thing that's going to change is going to be 3 and 2, 2 and 3, right? So in other words, it's not 2 and 3 anymore. It's now going to be 3 and 2, right? That's another possible combination, right? And if you notice, that combination is not in the shuffling one that I did earlier. Now I'm going to move on to the next one, right? To 2. I'm going to lock 2 in. And I'm going to swap 1 and 3, meaning 3 is here and 1 is there. And last but not least, I'm going to lock in the last element. And I'm going to swap the first 2. So 2 and 1. All right. And these here are all the different ways you can go ahead and arrange this, right? These are all different ways where you can go ahead and arrange this. But if you notice, if we start dealing with numbers even 4, right? 6, just strictly going to 4, this is going to be a lot of puzzling going on, right? There's going to be a lot, and there's going to be a high room for error, right? We're going to keep lost, right? We're going to lose track of things. But the great thing is that there's a formula for this, right? There's a formula for this. So how you would arrange this formula is there are 3 different slots, right? I'm not looking about the numbers. I'm looking at about the available slots, all right? These are all little houses, and the elements 1, 2, and 3 are in those houses, right? So I have 3 available houses, right? And you're going to ask yourself how many, if repetition is not allowed, right? If repetition is not allowed, you're going to start off with the max number of elements that you have, right? 1, 2, and 3, that's going to be, I have 3 elements, right? I have 3 numbers there. You're going to multiply this by another number, but since repetition is not allowed, it's going to be a number less, right? So that's going to be 2. And again, repetition is not allowed, so the last number is going to be 1. All right. So in other words, you're doing 3 times 2 times 1, which gives me 6, right? Which gives me 6. And now we're going to go ahead and move on forward to where repetition is allowed, right? Where repetition is allowed. So with repetition is allowed, it's going to be larger, right, than repetition not allowed, because that means what if you had a giant box of toys, right, and you had numerous Godzillas, numerous Iron Man, and numerous Transformers, right? So that means you can have 2 Godzillas and a Transformer, right? Ooh, so things are going to pick up even more, right? And of course, I want to go ahead and take the time to explain this, right? To go ahead and explain this. All right. So I know that I'm going to be including repetition allowed. I'm sorry, I'm going to be including repetition not allowed into repetition allowed. All right. So already in this list, there's already 6. But now let's start doing this with repetition allowed, all right? So how I want to do this is I'm going to include everything being 1, 1, 1, 1. Right there, all right? 1, 1, and 1. That's a possible combination because repetition is allowed, right? Another one would be 2, 2, 2, right? And another one would be 3, 3, 3. Okay. Going back to the triple ones, all right? A possible combination you can have is 2 1s in the beginning and a 2 at the end. All right. Another one you can have is 2 still dealing with 1s, but 2 in the middle. And again, still dealing with 1s, but 2 in the front. All right. And that's all really much I can do with that. But I can do more, right? I can do 1s in the beginnings with the 3 at the end, 1s on the sides, but with 3 in the middle, and 1s at the end with 3 in the front. These are all possible, right, with repetition. And if you notice this, I'm going to go ahead and follow the same pattern, but with the 2s, right? The same pattern with the 2s. So I can have 2 in the front, 1 at the end, 1 in the middle, 2 on the sides, 1 in the front, 2 on the ends. All right, I already did that with 1s. Let me do it with 2s and 3s. So I got 2, 2, 3, 2, 3, 2, and 3, 2, 2. All right, and that covers that one. Now let's move on to the last one, right? Here I have 3, 3, 1, 3, 1, 3, and 3, 3, 1. All right. Oh, no. Ooh, let me fix that. It doesn't even look symmetrical, right? There's usually a pattern here. There we go. And let's go ahead and do the 2. So this is 3, 3, 2. This is 3, 2, 3, and this is 2, 3, 3. Woo! Right? Right. Imagine we're only dealing with 3. So imagine whenever you're dealing with items in the hundreds or even 20. That'd be insane, right? For the exam, let's just say exam 2, you more than likely are going to have a problem like this, all right? You're more than likely going to have a problem like this and like this, where you need to show your work, right? We've already received our exam 1, and we see the importance of showing our work, right? You need to justify your answer. So you will be told to show all your work, right? Show all the possible combinations, right? Show all the possible combinations. I'm sorry, show all the possible permutations, right? Show all the possible permutations. Okay, so let's go back to the repetition allowed. This one here had 6 in total, right? That column had 6. This here had 3, 4, 5, 6, 7. That had 7. 7 as well. 7 as well, right? 21 plus 6. This gives me a total of 27 ways you can arrange these items if repetition is allowed, all right? But again, there is a formula, right? There were only 3 houses before, right? There were only 3 houses before. So those are going to be 3 slots available, right? And we started with how many items in the beginning? 3. Right, we started with 3. Repetition is allowed, so that means I'm going to multiply this with 3. And guess what? In the last end, repetition is allowed as well. So that is 3 times 3 times 3, which is 3 cubed, which is just 27. Which is exactly what we got. All right. So instead of writing these out one by one by one by one, right? Instead of writing these out one by one by one by one, right? We know that now with permutations, what we are able to do, right? Depending if we have repetition or not repetition. All right. So let's go ahead and move forward. Right. Let's go ahead and move forward to our first example. Right, visiting nurses. You want to know how many different ways can a visiting nurse, so one nurse visiting 10 patients, and she wants to visit them all in one day. All right, so in other words, they are 10 rooms. 2, 3, 4, 5, 6, 7, 8, 9, 10, right? There's 10 rooms. And right, it doesn't say repetition is allowed because right, her focus is only, or his focus is only, oh, her focus is only visiting a patient, right? As long as she visits all of them, that's great, right? It doesn't say that she right, there's no repetition involved. So that right, it starts with the 10th patient, then with a 9th patient, with an 8th patient, with a 7th. Right, and you go down all this list because repetition is not allowed. All right, and let's go ahead and plug that into our calculator, right? And what does it give us? For those that are using a TI 30X2S, right? This is my favorite calculator here. This is my favorite calculator, TI 30X2S. There's a great button, right, that we're going to be using in this class, right? We're going to be using in this class, and if for some reason I haven't mentioned your calculator, the other one is the Casio FX11ES Plus, right? So these are the 2 calculators that I had mentioned in the syllabus, right, that you could use for this class. Right. Start off with the TI 30X2S, right? There's a great way, right? This is a great way we can solve this because, right, this is going to get pretty tedious. 10 times 9 times 8 times 7. Ooh, right? And I'll mention something before I go ahead and tackle this problem. This is known as a factorial, right? A factorial looks like 10 and an exclamation point, right? It is not a screaming 10, right? It is 10 with an exclamation point. And right, and the factorial just means you're going to start at 10 and then you're going to go down that row, right, and be like 10 times the following number times the following number times the following number, right? Right. So, right, and you can go ahead and plug in 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1 in your calculator. But if you want to learn how to do it with a factorial, right, if you're using the TI-30X2S, you're going to go ahead and click on the prob button. Right, the prob button would be on the top left, right? The P or the probability button. And then once you click on that button, you're going to see on the 3rd slot an exclamation point, right? That's where it's at, right? So in other words, how you would type this in would be 10, right? You would type in 10 into your calculator, click probability, go over to the exclamation point, right? And now it looks like this. And when you click enter, it's going to give you 300, 600, what is that? 3,628, 800, right? That's what it's going to give us. Those are the different ways, right? The nurse can visit her 10 patients, right? So, right? So, and if you are using the Casio FX11 ES Plus, on the top right, you'll see a screaming X, an X with an exclamation point, right? It is right by the on button, right? And you'll see it highlighted in yellow. So all you would do is press 10. You would click on Shift. Right, Shift is on the top left, and then you would click on this button, right? The button that has X to the -1, and above it has that button, right? So Shift and that button, right? And then what's going to be displayed on your thing is a screen 10, right? And when you click enter, it's going to give you that value there. And these are using factorials, right? Using factorials. And if you don't have, and if I didn't mention your calculator or my instructions aren't clear, I would just Google it, right? You can Google it or YouTube it. Just type in the model of this and write factorial at the end. Right, so you can go to YouTube and just click a TI-30X2S factorials, and you'll see a great how-to video. Okay. So our second question, right? It's a secret code word. You want to know how many 3-letter code words can be made using the letters in the words bangles, all right? So one of the first things you want to go ahead and do is, how many words are in bangles? And how many words are there? We got 3, 4, 5, 6, 7. So we have 7 letters. Did I say words? I meant 7 letters, right? 7 letters. All right. So you may be saying, oh, well, are the 7 the houses, or are they going to be is it the 3? Yes, the houses, right? The available slots will be 3. All right, because this is how many 3-letter words, right? 3-letter words. All right. So for A, right, and we're going to go ahead and use what we learned, right, to go ahead and solve this. So I know I'm going to be using the 7, right, because there's 7 letters. And repetitions are permitted, right? Repetitions are allowed. All right. So this means that I'm going to start at 7, and I'm going to multiply this with 7, and I'm going to multiply this with 7. All right. In other words, this is just 7 cubed, right? And this is going to be 343. All right. All right, and for your exams, all right, if you're asked to show your work, all right, you would have to show pretty much what I have here, right? Pretty much that there. All right, I need to know that you understand how to do this. All right, putting just 343 will not be justifying your answer. All right, you need to show. I need to know that you know how to set these up. All right, for B, that is, repetitions are not permitted, right? So we said that that's like starting at 7 times 6 times 5, right? You just go down that row until the number ends. Can you do factorials here? No, you cannot use factorials here, right? You cannot use factorials here because it ends at 5, right? It ends at 5. It ends at 5. So this is just going to be, at this, I would just plug it into the calculator. 7 times 6 times 5. Right, this gives me 210. 210. Okay, I'm going to go ahead and talk more about factorials now, right? So for example, right, we said we could have 3 factorial, right? This is the same thing as 3 times 2 times 1 which is 6 times 1, which is 6. All right. And if you're writing these out, you might have noticed you don't have to write the 1, right? Because anything times 1 is just itself, right? Right. And a quick example, if you had 14 factorial, right, you would just do 14 times 13 times 2 times 1, right? Right. And if you want practice, right, let's learn how to put factorials into our calculator. And we get a very large number, right? Well, I'm just going to write this in scientific notation, all right? This is 8.7 times 10 to the 10th power. That's a lot of numbers, all right? That's a very, very large number, all right? We're going to see what are the properties of factorials, right? The properties of factorials. One being, what if they're dividing, right? What if we have 10 factorial divided by 5 factorial? Well, I recommend writing this list out, right? I recommend writing this list out, right? Oh, and just let me mention something before I go ahead and tackle this problem, right? Let me go ahead and move this one to the side. If you have, let's just say 6 factorial, it's up to you where you want that factorial to end, right? In other words, you can say this is 6 times 5 times 4 factorial, right? There's going to be reasons why you may want to do that, right? Right? You may be reasons why you want to do that, right? You can leave it like that, or you can just continue. This is 6 times 5 times 4 times 3 times 2 times 1. And you could have stopped at 5. You could have said 6 times 5 factorial, right? And like I said, there's reasons why we may want to do that, right? Let's go ahead and look at the problem we have up here. We have 10 factorial. So we know that's going to be 10 times 9 times 8 times 7, 6, 5, 3, 2, 1. At the bottom, I have 5 times 4 times 3 times 2 times 1. Right? And yes, things cancel out. All right, things cancel out, meaning I have 5, 4, 3, 2, 1. Right? Cancel out, meaning on the top, really, this just simplifies down to 10 times 9 times 8 times 7 times 6. Right? You don't have to find the full factorial at the bottom and then find the full factorial at the bottom if things simplify. Right? And another way I could have probably solved this, all right, to save us time would be 10 factorial, right? Let's do over 6 factorial. I would probably done 10 times 9 times 8 times 7 times 6 factorial divided by 6 factorial. And yes, right, factorials do cancel out, meaning I don't have to finish writing all those out. I know that this cancels out with this, meaning I just have 10 times 9 times 8 times 7. Right, and you would just simplify that, and that would be your answer. All right, so there's a reason why, right? There's a reason for this. All right, and right, we've been talking about permutations, right? We've been talking about permutations, and there's a great formula for this, right? There's a really, really great formula, which is n permutation R is equal to n factorial over n minus r factorial, right? N minus r factorial. All right. So the one thing you may want to use as a guide, right? One thing you may want to use as a guide is to remember your n is always going to be your largest value. All right. I understand whenever we're doing these, we might get confused. Like, hey, I saw this word problem. I know I got to use the permutation formula, but I got my n's and r's mixed up. Just remember, your n is going to be your largest one. So if you're watching the video, right, it's going to be very helpful. Right. So it gives me my permutations, right? And meaning, right, if I were to have told you evaluate this, right? Let's go ahead and evaluate this. All right. Let's just say I had let's see, 13 permutation 10, right? Then this is just going to be my n was 13, so this is 13 factorial over 13 minus 10 factorial. Right, so this is just 13 factorial over 13 minus 10, that is 3. So that's going to be 3 factorial, meaning, right, you can cancel these out, or you can just, plug it in, right? Plug the top and the bottom one. And I would probably do that just because it's going to be a while till I get to 3, right? 3 times 2 times 1 divided by 3 times 2 times 1. I don't know, these can cancel out, right? Leaving me with just 13 times 12 times 11 times 10. Right, and you would just plug those in into your calculator, and whatever it gives you, that is your answer. All right. So let's do some, let's apply this, right? Let's apply what we've learned. All right. Evaluate each of the following, right? So you're asked to, let's do A. Evaluate 1 factorial. Well, 1 factorial, right? That is just 1. And that's it. It's just 1. B. All right, you're asked 9 permutation 0. And by the way, if you're using a calculator, all right, if you're using a calculator, again, the TI-30X2S, right, my favorite calculator, you can type in 9, right? You can click on the probability button, right? And you're going to see 2 options, NPR and NCR, right? NPR and NCR. We're going to use the first one, right? NPR. You're going to go ahead and click on that. It's going to, so now your screen should look like this. And then you're going to type in the R value that you want, right? 0. All right. It's going to give you, all right. So if we were to do 9 probability NPR for 0, this gives me 1. Right? My answer was 1. Okay. Well, let's plug that in, right? Because for some of these, for the exam, I'll clearly state, hey, I need you to do these all by hand, or it's going to be, hey, plug this into your calculator. What do you get? All right. And if you're asked to show all your work for this, do it manually, right? You're right. We're gonna have to know, right? So you have to know both ways, right? So plug this in into the formula, right? We said here NPR was n factorial over the difference of those two, right? In other words, strictly n minus r factorial. So this is going to be n factorial over 9 minus 0 factorial, which is just 9 factorial over 9 factorial. And hey, this is nice. This is just 1. Right, this is just 1. All right. 12 permutation 12. This is 12 factorial over 12 minus 12 factorial. Right, this is 12 factorial over 0 factorial. And just so you know, right, trying to draw a start here. 0 factorial is equivalent to 1. Right, easy to remember that. 0 factorial equals 1. So in other words, this is just 12 factorial divided by 1, which is just 12 factorial, right? And let's go ahead and plug this into our calculator, right? 12 factorial gives me 479001600. Very, very large value, right? Very, very large value. This is 479,001,600, right? Right, and you would go ahead and do these with all of these, right? Right, that's how you would tackle on permutations, right? And factorials. So let's go and move on to the next problem. Right, it says here, sports sports car stripes. All right, sports car stripes. How many different 7-color code stripes can be made on a sports car if each consists of the colors red, black, pink, orange, blue, white, and green? All colors are used only once, right? All these colors are used only once, all right? So let's see here. What do I have? All right. I have, there we go. I have red, black, right? I have pink, orange, blue, white, and green. All right. So I have 7, right? Just making sure, all right? It's 7 of them. So I want to know how many different ways I can go ahead and do this, right? So this means that if there are 7 stripes on the car, right? Let's think about this. If there are 7 stripes, right? 7 colored code stripes, all right? That means there are, in other words, there are 7 houses. Right? There's 7 available slots for these colors to be filled in, right? And now I need to go ahead and look at the colors, right? I need to go ahead and look at my color options, right? My color options are red, black, pink, orange, blue, white, and green. Those are 7 colors. Right? So I know it's going to start with 7, right? And since these colors can be used only once, right? They can only be used only once, then I know this is going to be brought down in a chain. And hey, this is just 7 factorial, right? This is just 7 factorial. And what does that give me? When you plug in 7 factorial into your calculator, right? This gives me 5040, right? 5040, right? Very, very nice. Another way you can look at this, right? If you wanted to use, you're like, hey, can I use a formula? Yeah, you can, right? You can definitely use the permutation formula, right? You need to distinguish your N and your R, all right? Your N and your R. Your R is the objects that you have, right? Or I like to call them elements. Right? And N would be the order, right? You can think order, but I like to call them houses. It helps me to visualize that, right? So if my formula is NPR, then I'm looking for 7P7, right? Where again, you can put this into your calculator as well, right? You can go ahead and type in 7 probability NPR, enter, and then 7, and it's going to give that, right? In case you want extra, if you want to go ahead and look it up on your calculator, then definitely, right, for your calculator, I would Google or YouTube, type in your calculator's model and just follow it with permutation, right? And it'll show you how you can use that already preset formula. So for us here, this is going to be 7 factorial over 7 minus 7 factorial, which is 7 factorial over 0 factorial. And we learned 0 factorial with just 1. You're just looking at 7 factorial. Hey. And for extra practice, right, you can go ahead and see how, how this is applied, right, to all the previous problems we started. If you can use the formula, right, and if you can distinguish what is your N and what is your R. Very, very nice. Okay, let's go ahead and move on to the next problem. Okay, let's see here. So we have cell phone models. A particular cell phone company offers 3 models of phones, each in 6 different colors, and each available with any of the 8 calling plans. How many combinations are possible, right? So at this point, we're going to go ahead and be jumping into combinations, all right? The combination rule. And for those who are on the TI-30X2SS, right, my favorite calculator, again, in that probability button, you might have noticed there is the, right, that button, the NCR button, right? And the formula for the combinations, right, would be n factorial over n minus r factorial times r factorial. All right. That would be the formula. Right. And if you're trying to find out, right, how many different possible combinations are you able to get from these, right? This is going to be pretty straightforward, all right? I'm going to look at how many models, right, am I able to, phones do I have, all right? That's going to be 3, all right? I'm going to see how many different colors. Well, I'm going to multiply that by all the possible colors, all right? And then I'm going to go ahead and multiply that with the possible plants that I have, right? So with the possible combinations, right, if I would go ahead and multiply these, this here would give me 144. Right. So let's just say you're in a scenario where you only want to, right, we only want to choose, right, I'm only allowed to use, for these combinations, one model with one color, one model out of 3, with one color out of 6, and one calling plan out of 8. All right. So how this would look like for the model phone, right? This here would look like 3C1. For the colors, I would have 6C1. And for my calling plans, I would have 8C1. Right. I'm then going to go ahead and plug that into my formula, right? So you can, let's go for the first one. Let's go ahead and plug that in, right? This here gives me 3 factorial over 3 minus 1 factorial times 1 factorial. This gives me 3 factorial over 3 minus 1 is 2 factorial, right? And 1 factorial is just 1, meaning this is just 3 times 2 times 1 over 2 times 1, meaning this is just 3. All right. For extra practice, you can go ahead and attempt these next ones by hand. You may pause the video. And I find out this here gives me 6 when I plug this into the calculator. And you find out that this one gives me 8, right? And if I'm multiplying these 3, right, this gives me 3 times 6 times 8, which gives me 144. Right? And this right there is combinations. Right? And our next combination would be the Foreign Language Club is showing a 5-movie marathon of subtitled movies, right? How many ways can they choose 5 from the 6 available movies, right? So more of a real life world problem would be that, right? You have 6 different options. How many ways can you just choose 5 from the 6 available, right? So we said, right? We said, right? We may get confused, right? Like, hey, which one was supposed to be this one? You know, I got 2 numbers. Which one is which one? We said as a rule of thumb, you wanted to make your n the largest one, right? Right. So if you're using, right, this says use a graphing calculator, right? And that's exactly how it's going to be on your exam, right? If I really, right, there's going to be some problems where I'm not going to require your handwritten work. It'll clearly say use a graphing calculator, right? So this here in a graphing calculator or by hand would be 6 combination 5. Right, 6 combination 5. Right. Also with the formula, I'd have 6 factorial over 6 minus 5 factorial times 5 factorial, which is 6 factorial over, what's that, 1 factorial times 5 factorial, which this one just gives me 6 factorial over 5 factorial, and this is 6 times 5 factorial over 5 factorial. And I know these cancel out, right? Leave me with just 6. All right. So that's how you solve it by hand. All right. You can also, like I said, you can also just plug it into your calculator. Okay, let's go and move on to the next problem. Right. How many permutations can be made using all the letters in the word Hollywood? All right. How many permutations can be made using all the letters in the word Hollywood? All right. So let's see the total amount of letters that I'm dealing with. All right. Okay, let's see here. Okay, this is Holly, that's 5. Flex, give me 9, right? 9, right? 9 possible letters. Right. Okay. All right. So I see here that I had 9 total letters, right? In Hollywood. And whenever you're doing these, right, you need to go ahead and write out how many letters of each one do you have, right? So for my H's, I had just 1. For my O's, I had 3. For my L's, I had 2. For my Y's, just 1. For my W's, just 1. And for my D's, just 1, right? And what I need you to do is, it's going to be an extension of the permutation rule, right? Where you're going to have your total amount on top. And these R's are going to change depending on the different values that you had, right? And it's going to go on so forth until the end, right? So, all right, this is, how is this going to look, right? How is this going to look? So this is going to look 9 factorial divided by, let's start with up here all the way down, right? So I got 1 factorial times 3 factorial times 2 factorial times 1 factorial times 1 factorial times 1 factorial, right? And I can go ahead and disregard the ones, right? So if I had 1 factorial or 0 factorial, right, I can go ahead and disregard those, right? So technically you'll have is 9 factorial divided by 3 factorial times 2 factorial. And do not multiply factorials across, right? So that means 3 factorial times 2 factorial does not equal 6 factorial, right? So be careful with those. So one thing I would probably do is, I would say 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial all over 3 factorial times 2 factorial. And why is that? Because you generally want to go ahead and tackle out the larger ones, right? The larger factorials, right? So this is going to leave me with 9 times 8 times 7 times 6 times 5 times 4 all over 2 factorial, and that's just 2, right? And furthermore, right, 4 divided by 2 is 2, right? So you can cancel these out. So then in your calculator, you would plug in whatever works best for you, right? Best works for you. Let's see what this gets me, right? And another way you could have also done this is in your calculator, done 9 factorial over 3 factorial times 2 factorial, right? That's another way you could have done it too. So let's go ahead and see what we get. I get 30,240. Right, so that's how many permutations can be made using all the letters in the word Hollywood. Okay, go on to the next question. Right, so here we have evaluate each expression. All right, And again, right, this is pretty simple. It's pretty straightforward. We did an example like this before, so I'll let you use this as an exercise, right? I'll let you go ahead and handle this one as an exercise. Right, so for number 9, they want to know, let's see here, how many ways can 4 baseball players and 5 basketball players be selected from 13 baseball players and 13 basketball players? Right, and just like the cell phone plan ones, right? I'm gonna go ahead and focus on one item at a time, right? One group at a time. So I'm actually going to go ahead and focus on the players. Then I'll go ahead and look at the basketball players. Right. Regarding baseball, how many ways can I select 4 baseball players from the 13 that are in there? Right. So I know this is going to be 13C4. Right. For the basketball players, this is going to be how many can I select 5 from 13? So I know this is going to be 13 combination 5. All right. All right, and I'll go ahead and let you do this one by hand. All right. So 13, right? And you can go ahead and plug into your calculator as well. 13. This gives me this for the baseball I got. So I know I'm gonna have to multiply these, all right? So for the first one, I got 715. And what do we get for the last one? This last one gives me 1287. And when I multiply these together, this gives me 920,205. 920,205. Let's go ahead and move on to the next example. Right, in a train yard, there are 4 tank cars, 7 box cars, and 9 flat cars. How many ways can a train be made up, costing up 2 tank cars, 4 box cars, and 4 flat cars? Right. So again, this is very similar to the it's pretty similar to the other one, right? And here we go. Here's the hint. So you may be asking yourself, hey, is this a permutation or a combination? This is something I'll be throwing into the exam, right? And it goes back to this, all right? What I said in the first slide. This is very, very important. Right, so I know this is going to be a combination. So it's going to be something times something times something, and I'll go ahead and set it up for you guys. So let's look at the tank cars. All right, you can say, hey, I see that it says 4 tank cars on the top and then 2 at the bottom. I'm really confused. Well, if that was to happen, right, it'd be 4C2, and for the other ones it'd be 7C4, and then 9C4. Right, and I'll let you guys go ahead and solve this out, right? Okay, so for this next problem, we have selecting cereal boxes. Wake Up cereal. All right, that's the brand. Wake Up cereal, right? Comes in, copyright purposes. A Wake Up cereal comes in 2 types: crispy and crunchy. Right? If a researcher has 14 boxes of each, how many ways can she select 4 boxes of each for a quality control test? All right, for a quality control test. All right, so, all right, what you would do here is, let's go ahead and see what we have here. So it has 14 boxes of each. So in other words, I'm going to look at just my Krispies. right? Again, this is just like the basketball, baseball players, but you know, it's the wording, right? So this is crispy and this is crunchy, right? For crispy, right, she has 14 total, 14 total boxes, and she wants to select four for that one, right? And for the crunchy is the same thing, right? You have the total amount of 14, and you want to go ahead and select four, right? In other words, I'll be multiplying these two cases together. Right, and this gives me 1,001. 1,001 to the 1,001. And this gives me 1,002,001. Right, 1,002,001. Okay, let's go ahead and move on to the next problem. Right. Right. They are 19 seniors and 18 juniors in a particular social organization, right? So this can be something like, right, the type of students at like the at the honor college, right? If you have an organization like the honors college and you got 19 right seniors in there and 18 juniors, and in how many ways can two seniors and three juniors be chosen to participate in a charity event, right? So how many ways can be chosen, right? So, right, the seniors I have are 19 and 2, so 19 total, but 2 have to be chosen from there. And for my juniors, it's an 18 total with only 3 being chosen from there, right? Let's go ahead and select that. So 19 NCR 2, I get 171 times 18 NCR 3. This is 816, right? And 816 times 171, this gives me a lot of different ways that can be chosen, right? There's a lot of different ways that can be chosen. So that is 139,536, right? Okay, let's go ahead and move on to the next problems. Right, and this is going to go ahead and be the last one we'll be doing, right? Because I'm hoping that at this point we're really understanding how to tackle down the permutations and combinations, right? For example, for this one, how many ways can a person select 10 DVDs from a display of 11 DVDs, right? Ooh, movies, right? Movies are awesome. So again, right, your total amount, right, your complete your housing is going to be 11, right, and you're selecting 10 from them, right? So I'll go ahead and let you guys plug this into your calculator, and I'll go ahead and see you in part 4.5.